Hey guys, this is Miss Michael again, and I'm not reinventing the wheel. I'm using a video I like to use in class. And today we're going to be comparing convergent evolution and divergent evolution. So get out your notebook, be prepared to pause the video, and write down some important things about divergent and convergent evolution. So we're going to start with divergent evolution. Are you ready? Have you gotten your notebook out? Okay.
So in divergent evolution, two or more distinct species share a common ancestor from which they both diverge. A common example is the modern elephant and the woolly mammoth. They share a common ancestor and yet evolved into two different species. Another example is the dog, the wolf, and the fox. Again, they share a common ancestor yet evolved independently, right? They all diverge from a common ancestor. Now let's contrast this.
Okay, so let's go back to divergent evolution here. So, divergent evolution, what are some other terms that we're missing from this little video clip? It means that there's a common ancestor. So, under divergent evolution, we have speciation, we have adaptive radiation, all of these things, homologous structures. These are things that you need to write down because these terms also fall under divergent evolution. Remember, homologous structures mean there is a common ancestor. And when two or more species have developed from a common ancestor, that's speciation. Again, adaptive radiation is when several species have diverged from a common ancestor. So, all of this terminology, again, homologous structures, speciation, adaptive radiation. This is all terminology that falls under divergent evolution. And what does divergent mean? Diverge means it was once together, but it has diverged or moved into different directions. Diverged. It has diverged. So divergent evolution, common ancestor, homologous structures, speciation, adaptive radiation. This is all. These are all terms that fall under this type of evolution.
Now let's contrast this with convergent evolution. In convergent evolution, two or more distinct species share traits not due to a common ancestor. So let's take birds, bats, and butterflies, for example. All have wings that allow them to fly, but they don't share a common ancestor with wings. So each one evolved to have wings independently. Right? Evolution converged on a similar trait in vastly different species. Right? So their wings are not due to a common ancestor. All right, so let's recap. Divergent evolution is in vastly different
So I'm going to
species.
go back to this convergent evolution. Well, let's look at the butterfly and the bat wing and the bird wing. Okay, these are all similar in function, but they're different in structure. If you recall from our first unit of evolution, that would be an analogous structure. So, analogous structures are those are indicative of the same environment, a shared habitat. And convergent evolution doesn't involve a common ancestor, it involves a shared environment. Convergent evolution, analogous structures, shared environment. Okay, there's no common ancestor. These organisms are all evolving because of that shared living environment, that shared habitat.
Right? So their wings are not due to a common ancestor. All right, so let's recap. Divergent evolution is when descendants of a common ancestor evolved independently and uniquely, like the dog, the wolf, and the fox. While convergent evolution is when species share a trait not due to a common ancestor, such as birds, bats, and butterflies' ability to fly. And that's it.
Okay, so again, convergent evolution, analogous structures, common environment. Divergent evolution, common ancestor, homologous structures, and that those terms speciation and adaptive radiation fall under divergent evolution.